Hey, it's Mr. Ng going over your 1.3 lesson, and I just wanted to double check that I know some of you guys were typing these and I want them handwritten. So again, you can either print it and then take a picture of it. You can just copy all this down on a piece of paper like you would do in regular class, or you can make a copy PDF file and then do what I'm doing using a tablet with a stylus. Alright, our learning targets after this lesson, you should be able to make and interpret dot plots. When you see the word dot, I want you to think of dots. Of quantitative data, so then remember that's the number, that's one with numbers on it. Describe the distribution of, a distribution is just a set of numbers, and we're going to use an abbreviation called SOCs, and then we're going to compare distributions of quantitative data with dot plots. So what is a dot plot? So let's go ahead and define it. Remember, it is part of quantitative. They are numbers. And basically what we're doing is we're taking these numbers and then we're somehow giving some kind of representation to those. And so a definition of dot plots is shows each data value, trying something different with the black background, as a dot above its location on a number line. Has only a horizontal axis or number line. Dots are the same size. And equally spaced. It is very important to label the axes, sorry, because there's only one, and scale clearly. Alright, you don't need this one there. Let's talk about describing graphs. And when you see the word describing graphs, you should think of the acronym SOCs. And we're going to go over those. So this is the S in SOCs. So the first one is called shape. And the first one is called symmetric. What is symmetric? Same on both sides of the distribution. Remember, another name for distribution is also called a graph. There's a phrase we have. We say approximately normal. Alright, so let's give you our symmetric shapes. There are 3 of them. Start with the first one in the box on the left there. If you have this one, and you have a couple of graphs, this one they call bell-shaped. Bell-shaped. Why do they call it bell shapes? Because you're going to do this and another color might be helpful. You see this. That pink there, they call it, looks like a bell. And then they also call this one unimodal. And unimodal, uni means one. There's only kind of like one graph here. It's all lumped together. It'll make sense when I do the next one. All right, let's go to the next one. So let's say you have a graph. Sorry, screening the tip of my pen. Way better. And say it looks just like the other side. So this one, they would say there's kind of like 2 chunks. There's 1 and there's 2. Do you see the gap in between? So 2, they would say, is bimodal. There's 2 kind of big chunks there of data. And then you can just call the other one if you saw something. Well, count how many chunks there are. There are 3 chunks, right? 1, 2, 3. They wouldn't call that trimodal. They'll probably say they call this multimodal. All right. What is skew? What does skew mean? Skew means the tail. Let's make sure of the distribution determines the direction of the skew. Direction of the skew. I'll give you guys the 3 examples here. So this one we would say if a graph looks something like this and the tail is equal on both sides. So we would call this one no skew. If I draw another graph and we say all the data there is if I draw this little pink one, this might help. Oh, sorry. Bad one. Let's try that one again. This is my graph. And then so the tail is going over here to this side. What side is that? That is the left side. So we would call this one skew left. Skew left. The tail is going, which direction is it going towards? That's towards the left. And then if you did something like this. So over your bar graph or your histogram more accurately, then you're going to draw this, the bump, like a smooth curve over it. This kind of gives you the direction, so watch. And you're kind of like not touching any of those. And then the tail kind of goes off there. So it's going towards the right. So we call skew right. So another way you can think about it is, instead of skiing, which way should Mr. Ring go? Skewing. And the data, and this is actually an example below of the dot plot. It says go towards the long tail. So this would be skewed left. All right, that completes page 1. Go down to page 2. All right, so now we're on page 2, and what does a shape look like with its different types of forms? And one we didn't talk about is if all the data is exactly the same, we would say that this one is uniform. Like if all the students, you guys wouldn't like it, but if we all wore uniforms at school, you all look the same. If you all look the same, then we say that your looks are like constant. The frequency is constant, like the number of I don't know how many hours you slept, and all of you guys came in and you guys all said 8. Okay, so that's what your graph would look like. All right, let's go down to now the O in socks. What does O stand for? You might have actually heard it in another class. That's called the outliers. And what are outliers? They're AKA, also known as unusual values. Unusual values. So outliers are values unlike the rest. They're just different. Clusters are like isolated groups of data. Those are back to the modals, so I'm going to write that. Look above. Like the bimodals, unimodal. And then anything else is you're going to look for some gaps. Look for gaps. What are gaps? They are large spaces between values. All right, let's move on now to the C in socks. That is called the center. The center. What is the center? A typical value off in the middle, value that would best describe the center. Sorry, describe the distribution. Remember, distribution is just your picture of your data. So there are 3 ways of measuring the center. The first one is called the mean or average. And a way of finding it is taking the sum. And the sum, you're going to have these symbols. It's a backwards E, that's called a sigma, divided by the number of, fancy word, addends. Explain in a second. Here's my example. I'm going to have 3 numbers. How many Snicker bars did you have in the past 3 days? Maybe you had 1, and then you're really hungry. You got 7 of those the other day, and 7. Okay, so the sum would just be adding those up together. And then the addends is just how many numbers do you have. 1, 2, 3 numbers. And this would give you something called the average. I'll show you a future symbol as well. X bar. So that would be 1415 divided by 3. So our average or mean would be 5 is our answer. Let's practice boxing our answer. All right. The measures of center all start with an M. So here's the second one. And this is the median. And I'm going to highlight, this is the best one. Or the middle. Another way of thinking about this is, you know how at school, you guys are at the horseshoe in front of school, and then you want to get to the French fry place at the golf course, and then you got to cross the street. And then there's this thing called the median. It's in the middle of the road. So hopefully that helps you remember. So how do you find the median? Well, it's just the middle. So let's do another example. What are my numbers? Let's say you have a couple of numbers. 1, 7, 7, 9, and 22. I also want to emphasize, did you notice that they're in order from least to greatest? They call that, the numbers are ascending, because the numbers are getting up bigger. Okay, so I'm going to number these. So let's just say you have 1, 2, 3, 4, 5 numbers, okay? And you want to find the middle, right? The middle. So I have, this is how I do it. There are 2 to the left and 2 to the right. That means 7 is in the middle. 7 is the median. Okay, let's do another simple example. So let's just say I have the numbers 1, 5, 7, and 22. So what's the difference? The previous problem I had 5 of those. 5, right? 1, 2, 3, 4, 5. That was odd number of data. Okay, and this one has what? 4 of them. 4 is an even. Okay, pay attention now. I should have did it in a different color. Evens, well, you think about it. If I want 2 to the left, 2 to the right, then it's actually right down the middle. And what do you have to do here is you need to find the average of those 2 numbers. So 5 plus 7 divided by 2, what we just did in the previous problem. So 12 divided by 2 is 6. 6 is my median. Now you might say there is no 6 in the list of numbers, and it's correct. But to find it on an even set of data, you're going to have to find the average between those two numbers. Okay, so again, the first example was they were odd because there's 5 numbers. But in the second example, I had 4 numbers, and you have to find the average of those two because there is no middle number there. Mean, median, and last one is mode. So our third M is mode. And a phrase that helps you is most. What number comes up the most? Here's our example. I have 1, 7, 7, 9, and 22. And it doesn't matter, but a good strategy, again, let me highlight that, is you want to put your numbers in order. That way you can kind of see the numbers put together. Okay, so let's make it a little bit more complicated. Let's just say I gave you this set of numbers. Okay, this is how I would do the problem. Okay, so let's say I give you the white. Let's erase the orange. Okay, that was, and what I'm going to do is I'm actually going to just put these numbers in order. As I do them, I'm going to put a little check mark. Soup for helpful. Whoa, that was on erase. Soup for helpful hint. 1. Write it, smallest to greatest. Okay, 7. Put a check mark because these numbers are going to get like 20 numbers long, 50 numbers long, and you're going to lose track of all the numbers. That is actually one common way of missing the problem. You forgot one set of numbers in your data. Okay, so you just put them in from least to greatest, and then you're just going to pick which one happens the most or most often, and that is a 7. So the mode in this problem is 7. That's what we would say is our answer. Okay? All right, let's get to the last letter of SOX. We have S, stands for shape, O for outliers, C for center, and then S stands for spread. What happened? There we go, spread. If you guys are realizing we're going to be doing this every day, like, you know, it's a lot of information, and you might want to just, you can do what I'm doing. I'm using my iPad and not an Apple Pencil because that's pretty expensive, so I just got like a cheaper pencil. You can contact me and I'll let you know which one I got. Okay, so what is this? Determined by amount of data that varies from the center. Consider how close the data values are to the center. And if the data sets are close to the center, then there's little spread. And if the data points are far to the center, then there is more spread. A formula you might need is the range is equal to the maximum. So a way of figuring out the spread is using the formula for the range minus the minimum. And then here is my example. Here is my 2 pieces of toast. And we said if the data points are close together, pretend you have toast or bagel. Let's just say this is your jam. And the jam, just when you plopped it onto your bread, it was just really close together. That means there's little spread. Right? You're kind of thinking like, well, I got to get my jam all the way to the edges there. But when you plopped it on there, it didn't really do much. Now, if your spread, when you plop it on, whoops, that should have been blue. If it is far, right, way out here, then you have lots of spread. It's spreaded out all over the place. Okay, so that's how we would describe those. All right, so if you guys go down to the next page, here's our first example. I've given you gas mileage. How many miles can you go on 1 gallon? That's what it means to be miles. Wake up, pen. Miles per gallon. How many miles you can go on 1 gallon of gas? So you're going to use the following what? What did they give us? Here's the individuals. Those are the categories. We talked about that, right? And look at this data here. Are these words or are these numbers? They're numbers. So not categorical, it's quantitative. And in quantitative, they've given us numerical data or numeric data to create the appropriate graphs. The table in dot plot below displays the Environmental Protection Agency's estimates of highway gas mileage in miles per gallon for a sample of 24. So they're telling us, we have to double check, there should be 24 model year 2009 mid-size cars. Okay, so the first thing we need to do is create a dot plot. Okay, so dot plot, we're going to do the same thing as we've done with circle graphs, bar graphs. We're going to have a title. So my title is probably going to be something like 2009 mid-size cars. And I'm going to write in MPGs. You've probably heard a lot of car commercials for that. And here I'm going to write MPGs. And I forgot, we just took notes that there is no horizontal, or there's only a horizontal, no vertical. All right, so what do we do? So now you need to pick a scale. Look at all your numbers. And this is essentially kind of like your range. What is the maximum number that you have there? The largest number I see there is a 33. And then look at your minimum or your smallest number. I see a 14. That means that on my numbers here, I should go from a 14 to something with a 33. But 14 is even, so I'm going to move up 1. So I'm going to call that one 34. Okay, so here, maybe you want to count by 2s. 16, 18, 20, 22. Whoa, how did I do that last part? 24, 26, 28, 30, 32, and 34 is right there. Whew. I could have done a better job to make sure that they are equally spaced. I didn't do a good job of that. So if I had graph paper, it probably would have been better. Okay. Make sure you can see the data. And then for each data, I'm going to put a check mark. So 22. So let's find 22. And you just put a dot. That's called the dot plot. 23. Now look, you don't have 23 on there, so it goes in between. And you'll notice that, again, what we talked about, they're the same size and the same height. Super important. 14. Again, if you had graph paper, super would have been helpful. 28. Okay, what do you do when there are two of the same? Well, you stack them. It's kind of like your ice cream scoops. 25. 33. And 30. Now, I'm going to do something, and you don't have to at all, but that's just, I don't know, another way of organizing data or graphs or just using statistics in general. I'm going to switch colors to the second row. 30. Again, there's already a 30 there, so I'm going to change it. But now, why did I change colors? The colors don't really mean anything. It's just that now it's in the second column. The Hyundai Elantra 33. So I got to go between there. And then 25. And a 32. 26, 28, 29, and 24. Okay, and let's go ahead and try the last column, the last group. 24, 29, 27, 26, 18, 33, 31, and 29. All right, so there's my dot plot. And we're going to do that on the next part. And too bad. Oh, silly me. I created all that number line right here so that we can put it on there, but totally fine. Come on, Mr. Ring. All right, describe the graphs. Socks. I'm not going to put that reminder on there on your quiz, but remember socks. Socks represents what? Shape, outliers, centers, and spread. Tip, you have to explicitly compare these values using words like greater than, less than, or about the same. That's if when you're comparing. So let's do an example. Let's do one, shape. Now I'm going to draw kind of like your curve. So this is my tail, right? There's really nothing over there. So where's my tail going? It is going to the left. The shape is skewed left. Which means, or not like average, but is explained or defined that there are, you can use one of those words there, more cars or less cars than the 25 miles per gallon. Where's most of our data? Most of our data is on the right side, so we can say, which means there are a greater number of cars with 25 miles per gallon. Check how I used the word greater in there. I have the word skewed. You could have said something like multimodal, maybe, like what we learned above. That would have been fine. But the skewed is the big one. All right, let's look at outlier. Do you see any outliers that are unusual or don't belong to the group? At 34, there's a lot of cars getting good gas mileage. But look at that one over there, the 14. So what does that represent? The dot represented. And right now we're just going by visuals. We're not going by some formula yet. Representing (14) appears to be an outlier because it is isolated and causes a gap with rest of the distribution. All right, socks. We're almost there. Center. There were 3 measures of center. Mean, which is your average. Median, and your mode. Mean, median, and mode. Let's see if I can put this into a app. Let's use this thing. And this is just mimicking a graphing calculator. And this is one way of, instead of just doing all your numbers. So stat, edit. And what I'm going to do here is I'm going to go up to my list and clear it. And I'm going to put in all of those cars. So 22, 23. And I'm not an expert on each of your calculators, and nor can I. There's like 20 million calculators that each of you will bring, so I can't show for each one of you. But this mimics a TI 83, 84, and the different versions. 25, 33, and 30. So I got there by just going to stat and then edit. Now I'm going to put in the Dodge Avenger, Mantra, 33, 25, 32, 26, 28, 29, mistake up here, 33, 25, this is a 32, 26, 28, 29, 24, 24, 29, 27, 26, 18, 33, 31, and 29. Okay? And let's see if I did it correctly. You'll notice that it says 24 there. That means the 24 cars. All right, so notice how it's all under L1 or list 1. So I'm going to press stat, calc. So you're going to go over to the left now. And then you're going to hit 1 var stats. And let's see if they can just press enter. Oh yeah. All right, what does this all mean? Okay, the big thing that you need to know right there is X bar. X bar represents 26.9583. That's the average. So now I already know that the average is 26.9583. That's the X bar. And the middle of your data is, it says median. That's 28. All this other information we are going to learn. And one thing that's not on here is the mode. And you can just look at your list on your dot plots, and there's 3 of them, 28, 29, and 33. Okay? So that is one quick way that your technology, your graphing calculator, even your scientific calculator, just type it in. How do you find average? How do you find the median? It's just one. It's called one variable statistics. One variable statistics. There, that one part. That's just what this whole chapter is about. So let's go back. So our average was 26.96. Our median was 28, and our mode are three answers: 28, 29, and 33. Those are represented by they have three dots. Okay, so if I was doing that by hand, which I'm not going to show you because it would probably take me about a long time, I got to take this whole list, and you would have to basically let me get different colors. Try purple. You would have to list all of these in order. So again, use check marks. You would do something like this: 14. I'll just do the first side. 22, 23, and basically you got to sort all these numbers out. That's what you're doing by hand. 28, 28, 25, and a 33, and a 30. Does that make sense? And then if you put them in order, then you can just count how many numbers in the list. Well, this isn't even, we talked about, so I'm going to go between the 12th and the 13th number and find the average. That would give me the median. The mode you can probably see from the dot plot, and then the average you just need to add up all of those numbers and divide it by 24, which I think our calculator actually gave us 647. So technology is awesome. Figure out how to use it. Come to office hours. I'll try. I'm not an expert in all of those. Okay. All right. What is our last one? What is the spread? Hopefully you can see our SOCS, S-O-C-S. And our spread is, we can use that one formula, is basically you can use the range. The range is the max minus the min. And the greatest number we wrote on there at the bottom in blue, 34 minus 14, I'm sorry, 33. And if you just subtract that, then you have a range of 19. So you can say that the miles per gallon ranged from 14 to 33. That's a good way of describing our spread. Okay. Scroll down, go ahead and try the next problem. You're doing the same exact thing, but here's something that's different is you have males and females. So I just want to kind of help you start the problem. The females, all of these numbers right here, you're going to do down here. That's where you're going to put your dot plots. And so in some ways, it's kind of like two problems in one. And the male heights, you're going to put over here. Do your dot plot. You're going to do your socks. Females we did in orange. Just doing two separate problems. That's it. So go ahead and do that. Pause it. Use your data. Make a dot plot. Find your mean, median, mode. And then press play when you're finished. Alright, so hopefully you just did it on your own. If you want to do it with me step by step, feel free to do so. And so using the following numeric, data to create the appropriate graphs. Alright, so I'm going to do the same thing. I'm probably going to do the males first. And I'm looking for the smallest number there, and I see a 61 and I see a 60. So I'm going to put a 60 down here. And then I'm going to look for the largest number. Looks like the largest number there is 74. And I'm just going to count by twos. I'm going to zoom in so I can write that. 62, 64, 66, 68, oops, too much space, 70. It's okay, I can always erase. You should be using pencil and math, part of the 10 Commandments. Alright, there they are. And then I'm just going to go ahead and do a dot for each one. And then for each one, I'm also going to put a little check mark, right? So 62, 61, right there. Let's use pencil. $61, $63, in between 62 and 64, $65, $65, $64, $64, $66, $69, $72, $67, $70, $65, $74. See how these check marks are super helpful? 64, 60, 70, whoa. Push the page there, sorry. 68, 63, and 68. All right, let's go ahead and do the females. So again, I have the largest number I see there is 68. So mine, I'm gonna have 68, try to get there. And then smallest number I see is 58. So 60, trying to equally space these out, 62, 64, 66, and 68. So just raise that. And then I'm going to go ahead and check off. So I have still on erase. 60 and 59, 60 and 59, 62, 59, 66, and 65. Something kind of cheesy. I've seen students in the past try to cross off the numbers. You don't want to do that just in case you need to see the numbers later, especially if you're using pen. 60 and 62. 64. 68. 63. 58. 64, 64. 65, 62, 61, 61, and 60. All right, I'm going to do the males. I'm just going to write them from least to greatest, and then the females, I'll probably just give you the answer. So I can use this dot plot actually to an advantage because now I've kind of already listed out from least to greatest. How do I know that? There are only 160, 61, no 62, 63, 63, 64 three times, 65 three times. So there's an advantage of using the dot plot even in that way. 66, 67, 68, 68. 69, 70, 72, and 74. And do they tell us how many are in there? They did not tell us, so you can just count them. So let's count them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Look back at your list. 18. Is it even or odd? It's an even. 18 divided by 2 is 9. So the first 9 numbers. So that means my median's in between. If you count it, there are 9 numbers to the left and 9 numbers to the right. So basically we need to find the average of those two. Just do the math really quickly. 65 plus 65 divided by 2 gives me 130 divided by 2, which is 65, right? So when we are coming down here, What do we got? Socks. What does S stand for? Our spread. Where does our data look like? I don't know. All of our, remember, don't start where the line is. Start where your data is. I would say most of the data is over here. How do I know that? There's probably more dots on that side. You can count them. And so maybe if I do it more blue, it looks something like this. So if my data, the bump's over here, that means there's less over there. Follow the tail, so I would say this one appears, we're not saying exactly, appears to be skewed right. How would you compare this one over here? Again, draw something above it. And then where's all of our data? Our data is all on the left, and the tail goes to the right over here. So I would also say this one is also appears to be skewed right. Appears to be skewed right. That sounds right. All right, what's O? Outliers. What appears to be some unusual data? Just use pink over here. So those are kind of sticking out. Why? Because there's a gap right there. There's no number there. And it's possible you have some gaps over here too, right? There's a gap right here between numbers. So you could say that. Let's write that. There is unusual data at 60, 62, 72, and 74. Remember, there's going to be a formula later on. And then how about on this side? Is there any unusual data? There's a gap right there, so we could probably say that one. There is unusual data at 68. Or you can say something like, it appears to be an outlier. We're not assuming. Okay, so if you got your center, we said our mean, if you calculated it up, it would have been 66.211. You might be asking about decimals. More decimals, the better. Our median is 65, and the mode that happens the most, I didn't calculate that one. Let's see. I'm just looking at the bumps. That's a good way of using the dot plot. 64, 65. Okay, here's something that you can say. What do you notice about all three of these numbers? They're not too far off, right? And we said which one was the star. Which ones of these was the most important one? We said that the median was. So do you see how they're all close to 65? So we can say that the center appears to be 65 inches. Okay, let's do the females here. So average or mean, X bar, if you add all these numbers up, if you add all those numbers up, you should have and then divided by 19, you should get an answer of 62.263. So add all those numbers up and divide it by 19 because there's 19 females heights there, and that should give you that number right there. Okay, median. Our median is 62. I'm not going to do that for you, least to greatest, and then because it's, whoa. Did I miss a dot? The reason why I'm saying is they're 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh no, we missed a number. Super bad. Let's double check. 60, 60, 63, 63, 64, 64, 64, 65, 65, 65, 67, 68, 68, 69, 70. Up, there's another 70 in there. Bad. Okay, why did I recognize that? Because then the number of people, say n is your population or how many people's heights, there should have been 19. So that's 17, 18, and 19. So that's an odd number. And why is that important? Because we don't want the line there. The line will be, so there's going to be 8 numbers. Well. There's going to be 8 numbers to the left and 8 numbers, I can't count, 9 numbers, because 9 times 2 is 18, and there's also going to be 9 numbers over here. So that means that your median is 65. 65 still. And it didn't change, but I wanted to show that the number of males were 19. Okay. And then mean, median, and mode. What was the mode for our females? That was 60, 62, 64. 60, 62, 64. So what do all those numbers look like? It looks like the center appears to be what number? $62, which is what? Mean, median, or mode? The median. All these numbers are pretty close. Now our data is not really super skewed over. All right, so how can we make a comparison? So let's use those comparison words now. Comparison words, we're going to use like greater, less than, about the same. So we can say something like this. I'm going to abbreviate. The male center, which is 65 compared to 62, is what? Center is greater than. Greater than the female center. Or you can say it the other way around. You can say that the female's center, which is our median we're going to be using, because that's the best way of describing the center, is less than the male's. Okay, S for spread. Let's finish this up. The female's range is the lowest number, which is 58, to the maximum, which is 68 inches. And then the male's range is 60 to 74. And then you can write some kind of statement. I'll just write one here to compare. The male's max height is what? Greater, less than, or equal to? Greater than females. Max height. So those are our comparisons. So you could have done also something really interesting is you could have done a, I don't know, maybe make this up, a back-to-backs. No, it wouldn't work, but the cool technology part is if you could have, let's see if I could do that. What is that? Oh. And then the 74, I did the wrong one. I should have done the other way around. I was excited because I never done anything like this before. Move it on this side. 68. So if you match up the 68, something like this, you can already see that the orange or pink dots are more to the left and the males are greater in terms of max heights, right? All right, that was fun. Hopefully that was helpful for you guys in your notes. See you guys.
Love man. You don't love
Bye-bye.
man? What's wrong with you?